Good morning, class. This morning we are going to take a look at solutions and solubility. Let's look at the standard we're going to address this morning. Standard 6, obtain, evaluate, and communicate information about the properties that describe solutions and the nature of acid and bases. Use mathematics and compositional thinking to evaluate commercial products in terms of their concentrations, that is, their molarity and percent by mass. The learning target for today's lesson is students should be able to calculate molarity of a solution, and the assessment will be to ability to calculate that molarity of a solution. Now, what is a molarity? Molarity is a concentration that expresses the moles of solute in 1 liter. That word 1 liter should be stressed. 1 liter of a solution. That means if you are given centimeter cube or you are given milliliters, you have to convert it to liters. Right, 1000 centimeters cube or 1000 milliliter equals to 1 liter. Okay? So molarity M equals to moles of solutes divided by 1 liter solution. So moles of solute, in other words, is mass given divided by the molar mass. How do you get your molar mass? You look at your periodic table to get the mass. If it's a compound, you add them together. If it's just an element, you just write the element's mass. For example, how many moles are in 12 grams of sodium chloride? Moles equals to mass given over molar mass, and you are given 12 grams of sodium chloride. So you have to calculate the mass of sodium chloride. Sodium is 23, chlorine is 35.5. When you add them together, you get 58.5. So from the formula mass given over molar mass, you are given 12 grams of sodium chloride divided by 58.5 grams of the molar mass, which will give you 0.2 moles of sodium chloride. Is that clear? Good. Now the formula page, these are the 3 formulas that are associated with molarity. Molarity is equal to number of moles divided by volume in liter. Number of moles equals to molarity times volume in liter. This is just like cross multiplying to get the other one. Molarity times volume equals to this. Alright, volume in liter equals to number of moles divided by molarity. Now this is the unit of molarity. It is mole per liter. Mole per liter. 1 molar sodium chloride will give you 1 mole of sodium chloride, which is 58.5 grams, divided by 1 liter solution, which means you dissolve 58.5 grams of sodium chloride in 1 liter of water, and that will give you 1 liter solution of sodium chloride. That is what you call 1 molar solution of sodium chloride. Now, in other words, if you want to get 2 molar solution, what do? You multiply the number of grams by 2. You just double it and go through the same process. That means 58.5 times 2 will give you 117 grams divided by 1 liter of solution. We want to make 6 molar solution of hydrochloric acid, HCl. You multiply the total mass of HCl, which is 36.5, by 6. Dissolve in 1 liter solution. Alright, let's take an example. Sodium hydroxide is used to open stopped sinks, to treat cellulose in the making of nylon, and to remove potato peels commercially. If 4 grams of sodium hydroxide are used to make 500 ml of sodium hydroxide solution, what is the molarity of the solution? Alright? Calculation. Molarity of solution is moles of solute divided by volume. Alright? So step 1, find the moles of sodium hydroxide because you need the moles. If you look at the question, you are given grams and liters. You're not given moles, so you need the moles. So 4 grams of sodium hydroxide, remember how you've been doing it. Whatever you are given comes first. 4 grams of sodium hydroxide. And remember, you have to put your unit. Grams of sodium hydroxide will also be at the bottom here, grams of sodium hydroxide. Right? And whenever you are looking for grams, there's always 1 mole of that substance at the top. Remember the stoichiometry step we were doing the other day. So, in order to cancel these grams of sodium hydroxide, the grams of this sodium hydroxide must always be at the bottom so that they can easily cancel out. So you have 4 grams times 1 divided by 40 will give us 0.1 mole of sodium hydroxide. So step 2 is to find the volume in liters. Remember the question was given in 500 milliliters. And 1000 milliliter equals to 1 liter. So the same way, convert 500 ml to a liter. That means 500 times 1 liter over 1000 will give us 0.5 liters. So now we have our moles, we have our liters. So we can now use the formula at the top, moles of solute divided by volume in liters. And that gives us 0.10 mole of sodium hydroxide divided by 0.5 liters, which will give us 0.2 molar solution of sodium hydroxide.
Now it's your turn.
So let's see how you do this. A potassium hydroxide solution with a volume of 400 ml contains 112 grams of KOH. What is the molarity of the solution? I want you to pause and then solve this problem in just a minute or two. Step 1. Convert mass to moles. 112 grams KOH times 1 mole KOH over 56 grams of KOH. Remember, the KOH is the total, 56 the total mass of KOH. Potassium is 39 plus oxygen 16 plus 1 give 56 grams of KOH. And when you do that, you get 2 moles. Then you convert the 400 milliliters to liters. 400 times 1 over 1000 will give us 0.4. So now using the formula, you have 2 moles over 0.4 moles to give you 5 molar solution. So this is a pretty high concentrated solution.
Now it's your turn.
Alright, let's take another example. A KOH solution with a volume of 400 ml contains 2 moles of KOH. What is the molarity of the solution? Make sure you pause this video so that you have time to complete the assignment before you move on. A glucose solution with a volume of 2 liters contains 72 grams glucose. The glucose formula is C6H12O6. If glucose has a molar mass of 180 grams per mole, what is the molarity of the glucose solution? This is another example for you to work out. Take your time, pause the video before you solve the problem so that you have enough time to do it. Right, this is the solution. 72 grams of glucose was given, and the molar mass of glucose is 180. You convert 72 grams to mole, we get 0.4 moles. The molarity equals to moles over liter. Remember, you're already given a liter, so you don't have to convert anything again. So you just divide 0.4 by 2 liters. That will give you 0.2 molar solution of glucose. Now, this is your ticket at the door. I want you to complete this assignment and send it to my email or share it to me with the Google Classroom before the end of the day. Any late work will give you a late grade. Make sure you complete it on time and don't procrastinate. Send your response to my Google Classroom or send it to my email. Right, the second standard we're going to look at, or second section of it today is students should be able to calculate moles and volume of a solution, which of course is more or less what we've just been doing. Stomach acid is 0.1 molars HCl solution. How many moles of HCl are in 1500 ml of stomach acid solution? This is just like a review of what we did in the last lesson. So you should be able to go ahead and solve this problem now. Number of moles equals molarity times volume in liters. 1500 ml given times 1 liter over 1000, you convert it to liters, that will give 1.5. So when you do that, you have 1.5 times 0.1 molar, because 0.1 molar was given, and you only converted the 50 or 1500 ml to liters to give you that. So the answer is 0.15 moles. Second practice, how many milliliters of stomach acid, which is 0.1 mole HCl, contains 0.15 mole HCl. Volume in liters, same thing. Number of moles over molarity, 0.15 over 0.1. That will give you 1.5 liters. So the total is now 1500. You convert this milliliters, 1.5 liters to milliliters. The answer is 1500. Remember that your question was asked how many milliliters of stomach acid. So when you get your answer, you convert it to liters, milliliters. That's what we did now, because your answer was to be in milliliters. So practice question. Practice this problem. You pause the video and make sure you practice them before you move on. All right, we are putting on many things today. All right, the next one is students should be able to calculate number of grams dissolved in a solution. This is similar. We are still going to use the same formula. All right, using molarity. What mass of oxalic acid H2C2O4 is required to make 250 ml of 0.05 molar solution? Now in this case, your moles equals to molarity times volume. Change ml to liters as usual. You have 250 times 1 liter over 1000 will give you 0.250 liters. Calculate moles equals to step 2. Moles equals to 0.05 mole times 0.25 moles or liters, because moles is molarity times volume. That will give you 0.0125 moles. And to convert the moles to grams, remember you multiply 0.125 moles by 90 grams of the oxalic acid, H2C2O4. That means 2 hydrogen, 2 carbon, and 4 oxygen added together. You will get 190 ml, 90 grams per mole. So you multiply by the answer you got in step 2, which is 0.0125 moles. Alright, how many grams of sodium hydroxide are required to prepare 400 ml of 3 molar solution? Sodium hydroxide solution. So in this case, you do the same way we did it. Convert this to convert 400 ml to liters, and do that, and you get your final answer as 40 grams. This is where we're going to stop today. I'll see you again next period. Thank you.